Alright guys, Mr. B here again, bringing another sick, awesome, mediocre math video. This one again on everybody's favorite, trigonometric limits. And this one again is going to focus on using this guy right here to be able to solve limits. So the limit that we know and that we use frequently is limit as x goes to 0, sine kx over x is equal to k. So that's the one that I like to use, and hopefully, if this is new to you, you will like to use it too. Alright, so basically our idea is, how can we make this guy when we're given some stuff? So let's go ahead and try a few examples and see where this takes us. So, I've got cotangent here, so one of the identities that hopefully you've learned before is that cotangent theta is equal to cos theta over sine theta, so it's just the reciprocal of tan theta, which is sine over cos. So, how I remember that is C matches with the C if you need it, cos on top. And then we have limit as x goes to 0, 4 over x. So cos 3x over sine 3x. So I changed it right there. Now this looks a little bit silly, so I'm going to just sort of do this. Just drag it across. And what I want to do is I'm just going to flip this and multiply. So what this is going to do is that's basically going to rocket this sine 3x to the top when I flip and multiply this guy. So it becomes the limit as x goes to 0 of 4 sine 3x all divided by x cos 3x. So you can sort of see how this is shaping up here. I've got a sine 3x and an x, so I'm going to kind of match these together. This 4 I'm just going to chuck outside the limit because it doesn't do anything for me in here, so I'm just going to chuck it outside the limit. And then I'm left with sine 3x over x, so that's matching up these two, and then 1 over cos 3x. So that's exactly the same thing. I just rewrote it a little bit more friendly. Now the only thing I like to do is I like to make it really obvious to the teacher that I have that I understand what's going on. So the limit as x, which isn't necessarily all the time, by the way, because you know that's the type of person I am. So I'm going to just basically put this limit on both things just to show that I'm doing the individual limit of this guy and then the individual limit of this guy. So limit as x goes to 0 of 1 over cos of 3x. So the limit of this guy, I'm just going to use this rule up here. So sine kx over x is equal to k. So sine 3x over x is equal to 3. So I have 4. And this guy is 3 times 3. And then this guy right here. So the limit we need to know for that is a limit as x goes to 0 of cos x is equal to 1. So essentially, the reason why that's true is because cos of 0 is 1. Well, not essentially, it is the reason why it's true. So really, it doesn't matter what we have in front. It could be like, in this case, cos of 3x, which would be 3 times 0, which is 0. So, and that, of course, is still 1. Alright, so basically what we have is 1 over 1, which is just 1. So I end up with 12. And there's my limit. Alright guys, so that's the first example, and we used this guy, of course, everyone's favorite known trigonometric limit. If you're looking for a proof of that guy, it's not in this video, so I've said it before, I'll say it again. Alrighty, so this is another example of a proof where we have to use sine kx over x. So I will write this for you. So we know this trigonometric identity. I've used it in another video, guys. It's the Pythagorean identity. Sine squared plus cos squared is equal to 1. So this has a rearrangement that says sine squared a is equal to 1 minus cos squared a. So if you look at this, what we have is 1 minus cos squared of 5x. So that's really the same as sine squared to the sine squared of 5x. So I can rearrange this and get left with limit as x goes to 0 of sine squared of 5x over 5x squared. So remember what I want to do. I want sine kx over x. So in this case 5x. So I have sine squared. So sine squared is the same as sine times sine. And I have an x squared on the bottom. That's the same as an x times an x. So I want to break them up so they're just x and just sine. So I'll take that 1 over 5, that 5 that's on the bottom, I'll make it 1 over 5 and chuck it outside the limit. Just get it out of the way. We don't need it, so we're just going to chuck it outside. And then I have sine 5x times sine of 5x, all divided by x times x. So the 5 is out here, 1 over 5. And then I broke this up into sine 5x and sine 5x, and the x squared and the x times x. So you can see what I have. I have, right here, I have sine 5x over x. And I have sine 5x over x, which is essentially this. So sine kx over x is equal to k when we take the limit of it as it goes to 0. So again, you know how I roll. I like to show the teacher that I want to take the limit of each of these things individually, so I write that out. Really careful with trig limits especially. So then that leaves me with 1 over 5 times 5 times 5. Each one of these is just 5 because that's the number, that's the k value. So one of these sets of 5's cancel, and then I'm just left with 5. So the limit of this guy up here is just 5. Alright, let's try the next one. So the next one's actually starts in a similar place to where we ended up with in that one. So again, I can kind of take the number that's in the bottom. I didn't really think that example through. I should have done this one first. And then I take the 1/2 out, and then I'm left with the limit as x goes to 0. And then what I'm going to do is I'm just going to break it up as sine 5x times sine 5x all over x all over x. I'll save us a bit of time in this one, guys. I'm not going to rewrite it. So sine 5x over x is 5. Sine 5x over x is 5. So that's 25 over 2. Alright, so that's a fairly straightforward example as well, guys, but still it's fairly important to be able to recognize that's such an important skill, to know how to break up sine x squared and write it like this. Alright, the last one. So we'll see where this goes. I'm not entirely sure. I saw this one similar to it, and I said I'll give it a shot in the video. Let's see how it goes. Could go horribly wrong, might go horribly well. So, if that's possible. So the first thing I'm going to do is make my life a little bit easier and just take out a 2 here. So if I take out a 2, I'm left with 1 minus cos x all over tan 6x. So I'm going to take that 2 right to the outside. Just like that. And have 1 minus cos x all over. Now we know that tan theta is sine theta over cos theta. Alright, so I'm going to change this guy to sine theta over, not theta, sine 6x over cos 6x. So now I'm going to flip and multiply that. So what that ends up is my sine's on the bottom, my cos 6x burns it to the top. So I'm left with 2. The limit as x goes to 0. And then what do we got? So we got 1 minus cos x times cos x all over sine of 6x. So I'm still in indeterminate form right here. So one of the things I can do now is I'm really close to sine 6x over x. So what I want to do is divide the top and bottom by x. So I divide the top and bottom by x. And I tell you what I'm going to do. I'm going to stick that x on the top with the cos here, and then leave this cos by itself, and then on the bottom sine 6x over x. So I'm going to leave the x with this guy and the x with that guy on the bottom there. Okay. So another limit we know is limit as x goes to 0 of cos x minus 1 over x is actually equal to 0, I do believe. So what we can go ahead and do with this one is to sort of rearrange this a little bit. So you kind of see where this is going now with a disappointing ending. So the limit as x goes to 0, and I'm just going to rearrange this guy so it looks more like that. So what I can do to do that is take out a negative. So if I take out a negative, I get left with cos x minus 1 all over x times cos all over sine 6x over x. So what I do now is I take the limit of each one of these things individually, So it's cos. So 2 is from this guy. This guy right here has a limit of 0. This guy has a limit of 1. This guy in the bottom, sine kx over x, which is k, which is 6. But it doesn't matter because it's all right there. Alright guys, I hate when we get limits that equal 0. It just irritates me. I love getting a number back, but it is what it is. So it's one of those things that you got to know your known proofs. So that's the kind of the key to this guy right here. Yeah. So thanks for watching, guys. I'll see you guys in class. And if you like this video, if you like my page, just give it a share. I'm trying to push this thing, guys. I'm trying to help this math students of the world, and you know, have a bit of fun at the same time. All right. Thank you, guys. See you guys in class.